All right, Algebra 1. We got a pretty easy lesson tonight, so this is going to go by pretty quick, okay? So follow along and make sure you're paying attention. Uh, lesson 10 is probably one of the easiest lessons out of this whole entire unit. All we're going to be talking about is true-false statements, okay? So I want you to think about this, all right? Consider the statement. The President of the United States is a United States citizen. Is the statement a grammatically correct sentence? Well, ELA is not my strong suit, but I would say yes, it is, except for one mistake, okay? I would sit here and say that this right here needs to be a capital P. The President of the United States should be capitalized, okay? What is the subject of the sentence? That's the President. What is the verb? Is the sentence true? Yes, it is. That is a true statement. Okay. Now look at B. The President of France is a United States citizen. Is the statement grammatically correct? Again, I would say that that should be a capital P. We're talking about a person here, the President. All right. What is the subject of the sentence? President. What is the verb in the sentence? Is. Is this sentence true? No. The President of France cannot be a United States citizen. It's not a true statement. All right. Consider the statement 2 plus 3 equals 1 plus 4. This is a sentence. What is the verb of the sentence? Equals is the verb. Okay. What is the subject of the sentence? 2 plus 3 and 1 plus 4. Okay. Is the sentence true? 2 plus 3 is 5. 5 equals 1 plus 4, which equals 5. Yes, this is a true sentence. All right. Consider the statement 2 plus 3 equals 9 plus 4. Okay. We know we got the equal sign. 2 plus 3 is 5. 9 plus 4 is 13. Does 5 equal 13? No, it does not. This is a false statement. Okay. This is true. This is false. This is true. And this is false. Okay. What we're getting at is simple. A number sentence is a statement of equality between two numerical expressions. 2 plus 3 and 1 plus 4 are numerical expressions. That is a number sentence. A number sentence is said to be true if both numerical expressions are equivalent. Okay, that is to say both evaluate to the same number. Okay, so 2 plus 3 and 1 plus 4, that is equivalent. That is 5 plus equals 5. That is a true numerical expression. That is a true numerical sentence. Whereas 2 plus 3 does not equal 9 plus 4. All right, so let's look at some practice here. Okay, so whatever problems I do, those are obviously the ones you're not going to do. Whatever problems I don't do, you're going to have to do, okay? 4 plus 8 equals 10 plus 5. Well, 4 plus 8 is 12. 10 plus 5 is 15. That is a false statement. They do not equal each other. Easy enough, right? All right. 1/2 plus 5/8. Okay. Well, I can tell you right now, 1 plus 5/8, all right, that is going to be a little bit over 1. Because, let's see here, just to make sure I remember my fractions here correctly here. All right. 5 divided by 8 gives me, okay, so 1/2 is 0.5 plus 0.625. Together, they give me a value of 1.125. All right, that's supposed to equal 1.2 minus 0.075. All right, well, I can tell you right now that 1 2/10 does equal I'm getting ahead of myself here. 1 2/10 minus 0 75 thousandths does equal 1 125 thousandths. Okay, so this is a true statement. Okay, all right, now look at this C. 71 times 603 times 5,876 equals 603 times 5,876 times 71. All right, so two things are happening here. You've got the associative property, all right, and you have the commutative property all taking place here. all of these state that you can rearrange the numbers and change the grouping without ever changing the product. 71 is here, 71 is here. 603 is here, 603 is here. 5,876 is here, 5,876 is here. Those numbers still exist in the same place. So this is a true statement. Okay? I want you to do, on your own, D, E, and F. Okay? All right, so G. This is a very interesting problem, okay? Because we're dealing with square roots. Whenever you have the square root of 4 plus 9, okay, like this, written like this, remember what you have to do. This is still going to have to follow PEMDAS. The parentheses have to be solved first. So this is the square root of 4 plus 9, which is 13, equals the square root of 4, which is 2, plus the square root of 9, which is 3. The square root of 13, let's see, 13 square root, oh, well, my bad. Let's clear all that out. So square root of 13 equals, and it will not give it to me, there we go, equals approximately 3.61. And that does not equal 5. This is a false statement. Okay? Easy enough, right? You're just verifying whether or not both sides are equal to each other. All right? Do H, I, J, K, and L tonight for homework, along with D, E, and F. All right? If you guys are able to get all of those correct, all right, then we will, then tomorrow we will continue on with what's left in exercises 3, 4, 5, and 6 in the book. Okay, I just want to do a short introduction to this lesson, and I want to make sure you understand how to determine whether or not statements are true or false. Okay, so as a matter of fact, let's go ahead and finish this off. Do M and N for me as well. Okay, do all the remaining problems. If we get the exact same answers and we all know that these are true or false statements, then we will continue in class and we will finish up this lesson in class. All right? Because the rest of this stuff I much rather prefer doing with you in class so we can ask questions as a give and take. All right? So easy peasy, short lesson tonight, mainly because I want to do a little bit more work with you guys in class tomorrow on this lesson. All right? So with that being said, I want you guys to have a good night, and I will see you bright and early in the morning.